The only thing that is more annoying than code that crashes is code that crashes without it telling you what went wrong. I have been writing code for years that when it went wrong, it just crashed. I had no idea to figure out what went wrong, what was the situation like that caused this issue, and I didn't know how to fix that for the next time this particular code ran. So that is not only annoying, it also makes it really hard to run our code in production, because if things fail in production, you have no way to figure out how to save it next time. Thankfully, I learned 3 functions that are easy to mix and match to avoid this whole conundrum. It allows you to either save the code when things went wrong so that the code can continue running, or it will throw a bunch of diagnostics so that you know how to figure out what went wrong. So in today's video, I'll show you how these functions work. So let's dive in. In my R script here, I have a bunch of code that mimics how code often is structured. You know, there's a function that reads something, then there's a function that actually wraps that kind of function. You want to have this reading function as part of other functions, and then you want to use the data that you read in from a file to calculate some average or some other number, and at the end of all your function definitions, you call your script. It's a bit of a convoluted example here, but it mimics how the real world behaves. So what will happen here as I execute this is that I'm trying to read a file that I actually don't have, and it will cause an error down the line here. And I'm running positron here, so this is why there's already some cool error handling baked into this that makes it super easy to figure out what went wrong. So as I execute this, you see that there is an error message. It says read temperature log inside had an error. That's actually the innermost nested function, so that's already cool. I already know where this error occurred. It is saying file doesn't exist. That's my error message, but crucially it also shows you a traceback, and it shows you that it was sourcing my script, then it was trying to run this average temperature, this one tried to call the mean function, this one tried to call the read temperature log function, and then this one tried to call read temperature log inside, and this is then where the error occurred. So this kind of traceback helps you when you're running things interactively, but when you're running R, for example, in production on some machine that you don't interactively work with, then you don't have the nice features of positron for you. So to show you what would happen, I could just create an R terminal inside of my console, and then I could copy and paste the code inside and show you, okay, it would normally just give you this error. It will at least tell you where this error happened, and it give you the message, but it doesn't give you this nice traceback. So this is already much trickier to figure out. If you don't know how your code is structured, you'd first have to find out, okay, when is this function actually called? There is no tracing of the nesting. But what you can do, and this brings me to my first function that helps you write more understandable code when things go wrong, is to use the CLI abort function from the CLI package. So instead of creating error messages or errors with this stop function, you could use CLI abort, and then you could just take the exact same code. Let me make some space here, throw that inside, and now as I execute this, there's this even colored error message, and it says run rlang last trace to see what went wrong. Can do is to follow this exact instruction, and there you go. Things are automatically captured inside of this trace, and this is something that you can combine with the other functions I'm going to show you. So using this CLI abort function is a very simple thing to do, but it helps you a lot down the line. So CLI abort is one function that helps you a lot when dealing with errors. The next one that I want to highlight is tryCatch. It also sounds very simple, but in combination with CLI abort, it allows you to do a whole bunch of stuff that you probably wouldn't be able to do if you used either CLI abort or tryCatch. To show you how that works, let's actually just wrap our code here into tryCatch, and inside of tryCatch you will have to specify what's supposed to happen on errors. And for that you can specify a function that takes an argument for the error object. You often call that e, and then inside of there you could, for example, use CLI abort again to throw a custom error message that isn't necessarily using this original error message. For example, you could say failed to compute the average temperature. Let me actually actually format this a bit here. And now if we execute this code, you see that, okay, it gives you the error message that we've just provided, and you still get a traceback, but this time the traceback isn't as nice because it is just telling you it ran into tryCatch and then it just showed you the error message that you provided. We'll fix that in a second, but the mechanism is kind of nice. You have an error and then you can do something despite having code that produces an error, and this is a mechanism to help you save the situation when something goes wrong. What you can also do inside of CLI abort is to say, okay, this is just a child of a different error. So you can say the parent of the current error is just the original error message. Let me actually throw in some line breaks here. And then as you throw this or as you execute this, you see that, okay, it shows you the original error message and then it shows you the other error message saying the original error was caused by error in this inside function and the error message was file does not exist. So immediately you do have an error message that tells you, okay, where is the innermost thing that went wrong. And if you wanted to add the trace to this, just like we've seen before inside of our terminal, I can actually open it here. It reminded us to run rlang last trace. This is how you get the last trace, hence the name. And we can actually also put the trace into our error here. So let's use trace and say, actually I copied the wrong thing. Let's use last trace in here. And there you go. As I execute this now, we see that I run into an error. And silly me, I forgot this last trace is that something that you call after the fact. When you want to trace back, you actually have to call the traceback function. So now if you do that, then we have this traceback here, but currently, okay, this is only still giving us the uninformative trace with the tryCatch, but we're able to fix that in a second. And this actually brings me to my third function that I want to show you, and that one is withCallingHandlers. So instead of using tryCatch, we could use this other function. So what we can do is use this withCallingHandlers. Nothing else needs to change. And now as I re-execute this, we see we have our traceback here, and now we have a more informative traceback. We have still this whole thing, the outermost function was called, then we went into withCallingHandlers, then into the mean function, then into the other functions. You get the idea. So this obviously begs the question, what's the difference between these two? When withCallingHandlers gives you so much more information, why would you even call tryCatch? Well, the thing is tryCatch can help you save things. It will actually allow R to continue on. withCallingHandlers will error anyway. It might cause some side effects, but at the end of the day, it will just crash. Let's see that in action. So here we have withCallingHandlers, our code from before, and I could say instead of calling my CLI abort thing, let me comment this out here. I could just say, you know what? When there is an error, let's just return number 2. Why not? And now as I execute this, we still see, okay, this is causing an error. Even if the last thing that we return is just something that could continue the calculations later on, we will just run into an error. But tryCatch is different. So if we use tryCatch instead, we see that, oh, no error here. And actually, if I just call it like this, you see that the result is actually returned. We could add follow-up calculations on top of this result. So that's pretty cool. tryCatch allows you to move on. But of course, you don't have to use either tryCatch or withCallingHandlers. The most powerful thing to do actually is to use both of them. And what makes this even better is if you throw in CLI abort into the mix. Let's see this in action for our example here. So here in our code, just to see what's going on, let's actually print our error object inside of our tryCatch currently. And now as I execute this, we see that, okay, it will just print this error message here, but actually I want to show you the structure of this thing. So let's do str instead. So there you go. You see that this E object is nothing but a list that has a message or a trace and all kinds of other stuff in here. It also has a parent. And the cool thing is that you can use the CLI abort function and attach other kinds of stuff to the error object. For example, inside of my inner error here, I could throw in path and say the path is the actual path that errored here. And now as I execute this, you see that in my error object, you now also see this path object. So what I could do now is to, inside of tryCatch, fetch that thing. So I could, instead of this STRE, I could say, you know what, print the path, and then you'd see it would print me the path that we've just extracted. So with CLI abort, you can crash your system, but you can also attach information to that crash. That's super helpful for diagnostics later on. Another thing you could do is to attach a specific class to this error object, say file reading error. And then inside of your tryCatch part, you could say, okay, if E class is a file reading error, I will just abort, actually bring this back here. And if this isn't the case, then my other code will run and I will just return the fallback value too. So here, as I execute this, we see that we get an error. And the reason for that is because you can see in our output from before, this class thing is an attribute that doesn't actually land in here like path did. Instead, it lands in the attributes class. And you already see that there are already a bunch of classes attached to this. So what we have attached on top of that will just land in here. And then you're comparing file reading error with a vector of length 4. And this doesn't give you the output that you want, because you need to have exactly one true or false and not a bunch of them. So what you do in these situations is you use the inherits function. So now no error anymore. And actually I need to stick E into this. So here we see that, okay, we get our file does not exist error because we have triggered a file reading error here. We are calling this on the error object. For example, if I were to throw in a different error here, we'd see that everything runs through. And if I just call this manually, we see that our fallback value actually works. So that's how you can handle different kinds of errors and actually throw different kinds of errors. This CLI abort function makes that really easy. Now I know I said we want to combine tryCatch and withCallingHandlers. And to do so, let's actually throw a warning when we use our fallback. So let's throw in from the CLI package, CLI warn, and just say using a fallback value. And now as I'm executing this, we see that currently an error is thrown. If I change the error again, you see that, okay, it is throwing a warning message. And to make this more interesting, let's actually randomly throw a different error class. So let's throw in a random value and say if that is less than 50%, then let's use this file reading error, and in the other case it's just something else. So now as I execute this, you see that randomly at a 50% chance I do get these error messages or just a warning. Now what withCallingHandlers allows me to do is to react to both. So what I could do is to wrap my tryCatch in a withCallingHandlers function call, and then actually wrap this into curly brackets. And then I could say, okay, for errors, let's throw in a function that targets the error condition. Actually, I have to put all of these outside the curly brackets. That makes more sense. And then for warning, I could also do something else with the condition. For example, what I could do is to write to a file that a warning or an error occurred. So in case of the error, I could take the cat function and say an error occurred, and I put it into a file called log.txt. And in the warning case, I could do the same thing. But of course, I wanted to use a warning here. To make this more interesting, we could throw in a timestamp here. So instead of just using this hard-coded text, we can create 2 lines with the paste function, and then we simply throw in this line into our messaging here. And now as I execute this, we see that argument is missing. I have a comma here. So now this works. And now doesn't matter whether it crashes or just creates a warning. All of these iterations will be put into my log file. And if I open up this file, you see only one error, and that's because inside of cat, I forgot the append is true. So now as I re-execute this a bunch of times, you see that's all going into one line. That's not really what we want. So let's also throw in a line break in here. And now as I've re-executed this, you see that, okay, now we have a whole bunch of logs and we can see when a warning occurred or an error. And that's the power of combining tryCatch withCallingHandlers and CLI abort, because it allows you to do a whole bunch of custom error handling. You have withCallingHandlers to handle all kinds of different errors, warnings, and messages. You just write a function what's supposed to happen with each thing. You can use tryCatch to catch a situation when it goes wrong, or just rethrow an error. But you can also equip these errors with parent information, traces, or other kinds of different custom information that you want to use. And here this looks like a really contrived example, so let me show you a more realistic one. So here I have a list of fake CSV files. Let's just assume that this data here comes out of CSV files. And what I want to do now is to create a CSV file that shows me what kind of values were problematic. So right now, as I were to execute this, nothing really happens. But if I were to actually read the CSV from the path I have just shown you, then you see here that, okay, this currently is just an empty CSV. But you can also see in my list of fake CSVs that there is a missing value. And this is the one that I want to put into quarantine and then let the code continue on. Now, the first thing that I need is a function that allows me to validate a file. So let's call a function validate file. It will take the file and the values of that file. So in our fake example here, just the CSV name and the values associated with it. And then it will just iterate over the values and validate each number. We haven't defined this validate row function yet, but that's what we're going to do in a second. And if it can validate this thing, it will just throw a success message. And if this whole file is done, it will say this file passed the validation. So as I said, we also need this validate row function that we've just used here. So let's define it. It will take the file, the row number and its value, and it will just check is the value a missing number. If so, it will use CLI abort with some error message, and then it will stick a custom class to this error object, and then also stick the information like the file and the row number to this error object. Next, what we need is a wrapper function around this validate file function, because we want to stick tryCatch in there for the error handling part. So let me just throw in the code for that. It's process sensor file, and it will just use tryCatch with this validate file function. And in case of error, it will CLI abort with the other object as its parent. But now we might have nested error objects inside of each other. You see this function here has as a parent this error here. So we might have to go down the chain of errors to actually find this error with class sensor corrupt row to extract the information from that error object of it. So for that, you can just create a little helper function called findCondition. It will check a condition for a specific class, and if that class is the correct one, it will just return this condition, or if not, it will check out the parent. And if at some point there is no parent anymore, it will just return null. That's the whole thing of this thing. So now we have all the ingredients together. So let's actually loop over our sensor files. So as I said, we're going to loop over our files here, and in there we're going to use tryCatch to call our process sensor file function. And if this one causes an error, then we're going to look for an error class of sensor corrupt row. This is the class we have attached earlier. So we already know if this type of error occurs, we can handle this. If something else happens, we need to rethrow the actual error. So let's check, is this thing actually null? It couldn't find this specific error condition. If so, then we're going to abort saying unexpected failure. But in the other cases, we can just throw a warning that we're going to quarantine stuff and then add another row to our CSV via the cat function. So now as I execute this, you see that there's a warning message and a bunch of other messages. That's the power of the CLI package to have these nicely formatted messages. And now as I read the CSV, you see that sensor 2, row 2 had a problem. And if you wanted to, you could use the withCallingHandlers function as an additional layer to put the warnings that our error handling throws into another log file. So we could take this, stick it into withCallingHandlers, throw the code in there, and say on warnings, we're going to just use the code from before to get timestamps to our warnings from before and throw that into additional file. So we're just going to throw in this stuff here from before, and now we can re-execute this. And in our log.txt file, we don't see that yet because we've actually still used the hard-coded stuff here. And what we can actually do instead of hard-coding this is to use the condition message from the condition object. And now as I execute this, you do see that, okay, there is my log from before, but you also do see these weird special characters. And this is ANSI notation for the coloring. The CLI package has a bunch of these nice colored symbols and text. And you also can see these in the messages, but it's not always easy to display this kind of thing in TXT files. So that is why you can use from the CLI package the ANSI strip function to get rid of this notation. And now as I re-execute this, Oops, it actually needs to go onto the message and not onto the condition object. So now as I execute this, you see that, okay, this is more legible in my txt file now. Nice. With that, we have learned about custom error handling and also about how to attach side effects to these types of error handling operations, or just in general messages that you throw as part of your code. I know that's a pretty tricky topic, but let me know in the comments if I did a good job of explaining this to you. Also, feel free to share in the comments what your favorite trick was. And now with all of that said, I say thank you for watching and I'll see you next time.